So this is angular momentum matrices part 2. So part 1 video link would be given in the description. And so in that part, angular momentum matrices for jz and j square, their form and their derivation, and how to derive that, like this. So how to, what is the formula for deriving jz elements of jz matrices and j square matrices, the form, why we are getting those form, all had been discussed in the previous video. So if you want that discussion, can refer to the link given in the description. So now let us see angular momentum matrices for j plus j minus first, and then from that we can get jx and jy matrices. So the matrix elements of j plus are given by, so this is the form of matrix elements of j plus matrix. So here bra j dash m dash and j plus jm ket is equal to h cat root over j minus m into j plus m plus 1 delta of j comma j dash delta of m dash comma m plus 1. So here if you see, had we have already discussed the meaning of this form, so it is given in the previous video part 1, angular momentum matrices part 1. So here j plus is first operating on the wave function xi of j comma m, and because of that operation it would have eigenvalue of j plus is nothing but, so j plus eigenvalue is nothing but h cut into root over j minus m into j plus m plus 1. So this is the eigenvalue of j plus matrix. So that is j plus operator operates on the wave function xi of j comma m. So it would give its eigenvalue, and what does this j plus operator does is it increases the value of m by 1. So it is a raising operator, so m changes to m plus 1, and again that's why we are having here m plus 1. So again it is multiplied with the conjugate of this function, conjugate of this wave function, that is xi of uh, j dash m dash. So its conjugate is nothing but xi star of j dash m dash. So integration of what we would get finally is this is a constant term, it would be taken out. So integration of xi star of j dash m dash into xi of j comma m plus 1 d tau. So that one would be equal to 1 based on the normalization condition when both Kronecker deltas, that is Kronecker delta of j comma j dash and delta of m dash comma m plus 1. So when j equals to j dash, then it would be 1, and when m dash is equals to m plus 1, then only it would be 1. So then only that matrix element would exist. So in the remaining cases, when j is not equal to j dash and even m dash is not equal to m plus 1, in that cases it would not, there would not be any matrix element. And why we are here, we are saying so initially we were saying for the jz and j square matrices m dash must be equal to m, but here we are saying m dash must be equal to m plus 1. Why means this j plus operator increases the value of m by 1. So it after operation it would give its own eigenvalue, and it increases the value of m by 1, and this whatever we get here must be equal to this m dash. So after operation we would have m plus 1 in the place of m, hence m dash must be equal to m plus 1. So that's why this is j plus matrix. So the non-vanishing matrix elements of j plus are given as, so these are the non-vanishing matrix elements, that is nothing but, so this is that. So j comma m plus 1, j plus operating on j m ket. So this is bra and this is ket, that is nothing but equal to h cut into root over j minus m into j plus m plus 1. So that is nothing but eigenvalue of j plus. So here after operation we would get m in the place of m plus 1, hence here m plus 1. So j equals to j, m plus 1 is equals to m plus 1. Only those matrix elements would exist, remaining matrix elements would be 0. So here it is given delta of j comma j is equals to 1, delta of m plus 1 comma m plus 1 is 1. So and all other elements of j plus will be 0. M will take values depending on values of j. So M values would depend on the values of j. So for a given m, for a given j, M will take the values from minus j to plus j with a difference of 1. This is we already know from the allowed values of angular momenta. So M can take values from minus j to plus j with a difference of 1 between those values. So minus j plus 1, minus j plus 2, like that. We need to go on increasing by 1. So finally we would get j. So and next thing is also j plus and j minus should satisfy the conditions. So these are the commutator relations conditions for the j plus and j minus matrices. So that is j plus j minus commutation is equals to 2h cut jz, and commutation of jz j plus is equals to h cut j plus, and commutation of jz j minus is minus h cut j minus. These are from the commutation relations you can derive by replacing j plus by jx plus ijy and j minus by jx minus ijy, and applying angular momentum commutations, we would get these values. So these j plus and j minus matrices must also satisfy these rules, they are saying. So accordingly matrices j plus and j minus will be of the form. So finally j plus and j minus matrices would be of this form. So this is the matrix form for the j plus matrix. So here it is given. So that is j plus matrix will contain only upper diagonal terms. So if we see the j square and jz matrix in that form, only principal diagonal elements are having, remaining all the elements are 0. We are only having principal diagonal elements. But in the case of j plus matrix, principal diagonal elements are also 0, or remaining elements are also 0 except the upper diagonal elements. So if this is a principal diagonal, then this would be called as the upper diagonal. So this is principal diagonal, so this entire thing, and this is nothing but upper diagonal, and this is nothing but lower diagonal. So for the j plus operator, upper diagonal elements would be present. Y means the value of m increases by 1 after the operation of j plus. Why we get this one is because m dash is equals to m plus 1. So because of that, only upper diagonal terms would be present. So why we are getting the such like that, we would see with the help of an example now. And let us see also see the form of j minus. So j minus matrix will contain only lower diagonal terms. So this is the form of j minus matrix. So here if we see upper diagonal, this is principal diagonal element, and this is lower diagonal elements, sorry, upper diagonal elements, but here lower diagonal elements are present, remaining all the elements are 0, because for the j minus matrix m dash must be equal to m minus 1. Because of that condition, you would have only lower diagonal terms and no principal and upper diagonal terms. So here you can see the matrix. So this is the state on which j minus would operate, and after that it is multiplied with the conjugate of this state. So this state, this is the state where j minus is going to operate, j minus xi of jm, and this is the state, complex conjugate state, where integration is applied. So that is xi of j dash m dash, that is xi star of j dash m dash, like that we used to do. So here j and m values are given. So for a given j value 0, m value must be 0, because it could have 2j plus 1 possible values, that is 2 into 0 plus 1, that is only one value, that is 0. Minus j 2 plus j means here 0 minus 0 or plus 0 is nothing but only 0, so it would have only one value. And for j is equals to half, minus j 2 plus j, that is minus half 2 plus half. So minus half plus 1 is nothing but half, so only two values, 2 into half plus 1, 1 plus 1 2. And next for j is equals to 1, we have three possible m values, that is 2 into 1 plus 1 is equals to 3. So minus j2 plus j, that is minus 1 2 plus 1, minus 1 0 1. So like that these many values are there for a given j value. Here also the same, j dash m dash. So that is the nothing but matrix element form. So now let us derive j plus matrix element for the j value is equals to 1. So for the j value is equals to 1, we are going to derive J plus matrix. So what we need to do is first, so for a given J value, M value. So here J value we have taken J is equals to 1. So when J is equals to 1, so 1 J values would always be 1. So let us give gap. So 1 1 1 0 minus 1. In the same way J dash M dash, so all the values are 1. J dash value and M value ranges from 1 0 minus 1. So we need to find J plus matrix now. J plus matrix. So how the matrix element could be found is, as we have already known, J dash M dash J plus J M. So first, so for the first element, first matrix element is this. So this 1 J dash M dash 1 comma 1, J M 1 comma 1. So 1 comma 1 J plus 1 comma 1. So when J plus operates on this, so it increases the value of M by 1, that is 1 plus 1. So 1 plus 1, that is 2. So for a given J value is equals to 1, for a given J value is equals to 1, M value 2 is not possible. So the wave function would not exist. So here value would not get increased. So that is for a given J value is equals to 1, M value of M value 2 is not allowed. Hence this first element would become 0. And next let us switch on to the next element, that is 1 comma 1 1 comma 0, that is 1 comma 1 J plus 1 comma 0. So in this case if we see where eigen J plus operates on this wave function, so it would give us eigenvalue of J plus is h cut into root over J minus M into J plus M plus 1. So here J is nothing but 1 and M is nothing but 0. J minus M into J plus M plus 1, that is 1 plus 0 plus 1. So that is the thing, and it would give us the same wave function, that is xi of 1 comma 0, and of course it increases the value of M by 1. So J plus is nothing, operating on this wave function would increase the value of M by 1. So M value here is 0. So 0 plus 1 is nothing but 1. And this here on the another side we are having this wave function, that is bra and this is ket form, that is this is conjugate form of this wave function, that is nothing but xi star of 1 comma 1 and integration of d tau. So based on this, so what we will get is h cut into root over 1 into 1 plus 1 2, 1 into 2, that is root 2 h cut, and this is nothing but 1 because here J is equals to J dash is equals to 1 and M dash is equals to 0 plus 1, that is 1. So here M dash is nothing but 1. This is M dash. Actually here J is equals to J dash. So this is J dash, this is J. And M dash is equals to 1. That is nothing but M dash is equals to 0 plus 1. That is M plus 1. Hence, when M dash is equals to M plus 1, then only we would have matrix element. So hence this element would become now root 2 h cut based on this. Hence we are getting this element. In the same manner, if we proceed for the next term, so for the next term, what we would have is 1 comma 1 operating on 1 comma minus 1. So what it actually does is, if we consider only the J and M values, so 1 comma 1 J plus of 1 comma minus 1. So this J plus increases the value of M by 1. So you would have 1 comma 0. But xi of 1 comma 0 and xi star of 1 comma 1 integration d tau is 0, because here j is not equal to j dash. Here it is xi of 1 comma 1, but here it is xi of 1 comma 0. So actually here j is equal to j dash, but m dash is not equal to m plus 1. M plus 1 we are getting 0, but m dash is 1. Hence in this case this matrix element will become 0, and that is the case. And now coming to the next matrix element, so 1 comma 0 1 comma 1. Here also j plus operating on this increases the value of m by 1, so 2 is not possible for j is equals to 1, so this element 0. And next element if we see, so if we think in the same manner as this wave function, if we think, so 1 comma 0 and j plus of 1 comma 0. So j plus increases the value of m by 1. We would have 1 comma 1, xi of 1 comma 1 and xi star of 1 comma 0. Hence this is not possible, because here j is equal to j dash, but m dash is not equal to m plus 1. So this term, these both are not equal. Hence this one would become 0. Hence when in the case of jz and j square matrices, when m is equals to m dash, that is principal diagonal elements 1 comma 1 1 comma 1 1 comma 0 1 comma 0, only those elements would become would be having some certain value. That is because of the condition m is equals to m dash, but here the condition is m is equals to m plus 1. Why means this j plus increases the value of m by 1, because of that condition only. So here also the next element is 0. And now considering the next element, that is so if we consider next element, so that is 1 comma 0 operating on j plus 1 comma minus 1, so it increases the value of m by 1. So here we would have 1 comma 0 as usual, so h cut into root over j minus m. Here j is nothing but 1 and m is nothing but minus 1. J minus m, that is j plus m you would have, j minus of minus m, like that we would have. So j value is 1 and m value is minus 1. So eigenvalue of j plus is nothing but square root of j minus m into j plus m plus 1. So next j plus m, but here we are having minus 1 plus 1. So this one would get cancelled, 1 into root 2. So root 2 h cut, and integration of xi star of 1 comma 0 into xi of 1 comma 0, as it increases the value of m by 1. So that one would be equal to 1. So root 2 h cut. So here this element would also be root 2 h cut. Now considering the next element, this. So here as usual it increases the value of m by 1, 2, which is not allowed, so 0. And here in this case it increases the value of m by 1, we would have 1 comma 1, but here 1 comma minus 1. So after application, so both are not equal, so this element would also be 0. And here after increasing the value 1 comma 0 we would have m value after operation, j plus operation 1 comma 0, but here it is 1 comma minus 1. So this element also would also be 0. So hence if we observe this j plus matrix for j value is equals to 1, so principal diagonal elements are all 0. Only upper diagonal elements would exist. So this is the upper diagonal elements. So in general we could write it as j plus divided by h cut. So this is j plus matrix. J plus matrix is equals to, this is the matrix, and if we take h cut as constant common out, so constant multiplied by matrix is nothing but each element multiplied with that constant, and that so like that. So that is k into matrix A B C D is nothing but matrix KA KB KC KD, like that. So if we take h cut as common, so sending this h cut to this side, so j plus by h cut, that is nothing but 0 root 2 0 0 0 root 2 0 0 0. So this is the j plus by h cut matrix. So now in the same manner let us find j minus matrix for the j value is equals to 1. So you would have jm and j dash m dash, that is j value 1 1 1 and m values 1 0 minus 1 and j dash value 1 1 1 1 0 minus 1. So now for this is for j minus matrix. So this would be of the form j dash m dash matrix elements. These are the matrix elements j comma m. So for the first element, if we see, so 1 comma 1 1 comma 1, so 1 comma 1 j minus 1 comma 1. So what does this j minus do? It would decrease the value of m by 1. So 1 minus 1 is nothing but 0. So 1 comma 1 1 comma 0, that is integration of xi star of 1 comma 1 into xi of 1 comma 0. So both are differing, so hence this term would be 0. And in the next case, if we see 1 comma 1 and j minus operating on 1 comma 0, 1 comma 1 j minus operating on 1 comma 0, so it would reduce the value of m by 1. J plus increases the value of m by 1, so this reduces the value of m by 1, that is 0 minus 1. So you would have 1 comma minus 1. So 1 comma, actually here 1 comma 0 was given, so you would have 1 comma minus 1. And next important thing is, so here if we see, this is 1 comma 0, but j minus operation, we would have 1 comma minus 1 0 minus 1, but 1 comma minus 1 1 comma 1, so this 1 1 are equal, but 1 is not equal to minus 1. So hence this also would be 0 based on orthonormality condition. And the next thing is this, so j 1 comma 1 j minus operating on 1 comma minus 1, so it would reduce the value of m by 1, that is minus 1 minus 1 minus 2. For a given j value is goes to 1, minus m value minus 2 is not possible, so this element also would be 0. So now coming to this element, so that is nothing but 1 comma 0 j minus 1 comma 1. So what does this j minus do after operating on this wave function is 1 comma 0. So xi of 1 comma 0 and its conjugate of this wave function is xi star of 1 comma 0 d tau, and its eigenvalue is nothing but h cut into eigenvalue of j minus is nothing but root h cut into root over j plus m into j minus m plus 1. So j plus m, that is 1 plus 1 2, 1 plus 1 2, j minus m plus 1 1 minus 1 plus 1, that is 1. So you would have root 2 h cut overall, hence this element is root 2 h cut. In the same manner, next element if we consider, so 1 comma 0 j minus 1 comma 0. So what does this j minus does is it decreases the value of m by 1, that is 0 minus 1, that is 1 comma minus 1. So here it is 1 comma 0, here it is 1 comma minus 1. So they are based on orthogonality condition, this term would be 0. In the same manner, next if we see j minus operating on this, so it reduces the value of m by 1, so this is m minus 1 minus 1, that is minus 2, so it is not possible. So next thing is, next again if we consider this element 1 comma minus 1 and 1 comma 1. So when j minus operates on 1 comma 1, it reduces the value of m by 1, so 1 comma 0 we would have. So here 1 comma 0 1 comma minus 1, so this element would also be 0. And next element if we see, so 1 comma minus 1 j minus 1 comma minus 1 j minus 1 comma 0. So this one would decreases the value of m by 1, that is 0 minus 1, that is minus 1. So you would have 1 minus 1 here also 1 minus 1, that is xi star of 1 minus 1 xi of 1 comma minus 1 integration d tau, and multiplied with the eigenvalue of j minus, that is h cut into root over j minus m 1 minus 0 1 into j plus m plus 1 1 plus 0 plus j plus m, we would have eigenvalue of j minus is nothing but square root of h cut into square root of j plus m, that is 1 plus 0 into j minus m plus 1 1 minus 0 plus 1, that is 2. So here also we would have root 2 h cut, this entire thing is 1, so root 2 h cut and this is 0. So this is the J minus matrix. In short, if we consider J minus by H cut, if we take H cut as the common and sending to that side, so we would have this matrix 0 0 root 2 0 0 0 root 2 0. So this is the matrix J minus by H cut matrix. So here principal diagonal elements are all 0, upper diagonal elements are all 0, only this lower diagonal elements we are having certain value. So this is nothing but J minus matrix for J values goes to 1. Now we need to find out Jx matrix and Jy matrix. How to find out is, as we already know, J plus is nothing but Jx plus Ijy, and J minus is nothing but Jx minus Ijy, Jx minus Ijy. So now what we have to do is just add it up. So on adding this one would get cancelled. So J plus plus J minus is equals to 2Jx. So if we divide entire thing by H cut, J plus plus J minus by H cut, 2Jx by H cut. So we could get this matrix. So that is nothing but, now what we have to do is adding J plus and J minus. So we have already got J plus by H cut and J minus by H cut. So on adding that, what we would get is, so this is J minus by H cut, and J plus by H cut is nothing but 0. Upper diagonal terms are present. So root 2, here 0, here also 0. So here root 2 0 0. So if we add these both matrix, what we would get is matrices. What we would get is 0. First element 0 plus 0. Next element 0 plus root 2. Next also 0 plus 0. So here root 2 plus 0, 0 plus 0, 0 plus root 2, 0 root 2 0. So this is the 2Jx by H cut element matrix. Sorry, this is 2Jx by H cut. So 0 root 2 0 root 2 0 root 2 0 root 2 0. Hence here we are having for J value is equals to 1 2Jx by H cut matrix as we have derived now. So what we have derived is this matrix only. This is the matrix we have derived by adding that J plus and J minus. So this is nothing but 2Jx by H cut matrices for different values of J's. For J value equals to 0, we would have 1 by 1 matrix as we have discussed in the previous video, that is 0. And this is 2 by 2 matrix, this is 3 by 3, and this is 4 by 4 depending on the values of J and their corresponding M values. So these are the list of matrices for 2Jx by H cut. And next thing is, now in order to find out Jy, what we have to do is subtracting these both equations, that is J plus minus J minus. So what we have is J plus Jx minus Jx would get cancelled. This one minus of this one, that is plus 2I Jy, and dividing by H cut and dividing this by 2i. So J plus minus Jy by H cut divided by 2i, that is so let us keep this 2 that side only, 2Jy by H cut. So that is high H cut. So what we have to do is subtract J plus and J minus and divide it by I. That is what we are having is J minus by H cut and J plus by H cut matrices. We need to subtract these both matrices and divide it by I. Divide the result by I. Then we would get 2Jy by H cut. So what does we get if we subtract means, here you can see. So J plus by H cut, this matrix minus this matrix. So that is nothing but 0 minus 0 0, root 2 minus 0 root 2, 0 minus 0 0, and 0 minus root 2 is minus root 2, 0 minus 0 0, and root 2 minus 0 root 2, again 0 minus 0, and 0 minus root 2 minus root 2, 0 minus 0 0. So here now if you see this is J plus minus J minus by H cut. Now we need to divide entire matrix by I into, that means we need to multiply it with 1 by I. So 1 by I is nothing but I into I by I, that is minus I. So we need to multiply this entire matrix with minus I. So if we multiply with minus I root 2 0, minus into, so minus into minus plus root 2i 0 minus I root 2 0 uh, I root 2 0. So this is the Jy 2jy by h cut matrix based on this formula. So we are having 0 minus I root 2 0 root 2i 0 minus I root 2 0 I root 2 0. That means we have derived this matrix, that is Jy matrix. So so these are the Jy matrices for different values of J and their corresponding m values. So for like this, we can find out Jx and Jy matrices from the corresponding J plus and J minus matrices. So this is the thing. So even in the previous video we have derived 2 by 2 J square and Jz matrices. So this is 2 by 2 Jy and Jx matrices. They are of the form Pauli spin matrices. So 0 1 1 0 0 minus I 0, and Jz matrix what we have got yesterday. So Jz we have got 1 0 0 minus I. So this is nothing but they are of the form Pauli spin matrices. This here, this matrix, this matrix, this matrix, if we take this constant aside. So if we, from the formula we know j square is nothing but jx square plus jy square plus jz square. So if we do square of this matrix, square of this matrix, square of this matrix, and add them all, we would get this matrix. So in the same manner as we have derived now 3 by 3 matrix, like that this 2 by 2 matrix jx jy could be derived. So this is the way of deriving J square as given in the previous video, part 1, and in this part Jx, Jy from the matrices J plus and J minus. So this is the way to derive these angular momentum matrices. So thank you.